Hi, my name is Matt. Today I'll be explaining how the graphs of functions can stretch and also shift. So let's get started. Um, right here, this is the graph of the equation y equals c times f of x. And in this case, c is 1 since it's the standard case. And that's the graph that we're showing. Now let's show how a graph can stretch. In this case, y equals 3f of x. The only difference here is that this original equation, f of x, is being multiplied by 3. So the only change in the graph will be, instead of being at 1, it'll come across at 3. And that should be a straight line. But then it comes down to -3, comes back up to +3, goes back down to -3 again, and levels out. So, as you can see, when c is positive, or when c is greater than 1, then the graph will shift vertically, and that's the only change. And then in the example y equals -2 times f of x, we have c being less than 0. So what this means is that the equation, since c is negative, the equation will be reflected over the x-axis, and then once it's reflected over the x-axis, you can treat it as if it's this case, c being greater than 1. So the graph of y equals -2 times f of x will be come across here and at -2, since it's flipped over the x-axis. Come up here to +2, down to -2, and up to +2 again, and across. And the only other case, which I'm not going to show graphically, but I'll show the equation for, well, I'll show the rule for c, is if c is in between 0 and 1. The graph will shrink vertically, as opposed to when it's greater than 1, it doesn't shrink, it expands vertically. Okay, now I'm going to talk about how graphs can shift, whether up, down, left, or right. So here we have the standard equation y equals f of x, and in this case y equals x squared. Okay, in order to shift this graph up 2 notches, all we need to do, y equals x squared plus 2. And the 2 is just simply because it was 2 notches up. Vice versa, y equals x squared minus 2 would look like this. It's the same equation as the original, just shifted down 2 notches. And now there's a little, so in general, for shifting up and down, we can say y equals f of x plus k. And k is just the distance that it shifts, whether it's positive or negative. Up obviously is positive, down would be negative. Okay, now in the case of shifting to the left or right, in general we can say y will equal f of x plus or minus k squared for our graph that we have right here. Okay, now to shift to the right, obviously, okay, we'll just have to be positive, so it would look like this, y equals f of x plus 2. We're shifting 2 notches to the right, and our graph would be there. The vertex of the parabola is just on 2. And now to shift to the left, it would be y equals x minus 2 squared, 2 notches to the left, and there we have it. So you can see this just simply relies on the value of k. If k is positive and simply added to the base equation that we have, it's shifted up. If it's negative, shifted down. And then if the k value is added to right to the x in the function, this causes a shift to the left or to the right depending on whether k is positive or negative.